Hello, welcome in another important video. I hope you all are doing great. In our previous video, we discussed about Docker network. Okay, we have created our first ever customized Docker bridge network. In this video, we will take this even further and we will try to create actual scenario where we will understand why do we need to create our custom network. Okay, so we will try to create real life scenario. So what I've planned to do here is I will create one container which will serve APIs, and we will create another container. That container, the second container, will try to ping APIs or try to access APIs of our container one. By default, Docker containers cannot communicate with each other because Docker believes in isolation. So every single container will run in the isolated environment. Okay, but in real life scenarios, we need to communicate with the Docker containers in order to get outputs from them. So we are trying to create situation here. Okay, so let's get started. So let me enter into the full screen first. Let me increase its font size. So this is a fresh server, so we need to create our network again. So let me use docker network command, and as you already saw, we need to specify type of network. So in our case it is bridge, and we need to specify name of the network. So I'll specify same name. I want my network name to be mynet. So that's it. Let me enter. Now our network is ready. So let me check that as well. Docker network. So as you can see, now we have one more network with name mynet2 once again. So in order to create the actual scenario, we will need one API server. Okay, so for that purpose I have choose this particular image, and if you want to see what it is doing, you can also refer this GitHub repository. So let me explain you in a brief. So this particular image is published by this particular user, and this is nothing but a basic Node.js API. Okay, it is using Express.js internally. I have already seen its code, so I can explain you. So as you can see here, it is using Express.js, and as soon as you try to access this APIs, it is only serving one API, and that is also get method, and that is also get API. And as soon as we connect to this server, we will be able to see this particular message. After that, we will create another container with Ubuntu image, and we will try to access this API from the Ubuntu server. Okay, let's try to do that. So let me go back into Docker Playground and let me use docker run command, and in here we will need to run this API server in dash mode, but I want its interactive terminal. I don't think we will need, but let's keep this for now. And we will need to open port number. Okay, because this image is serving some APIs, and that APIs will listen to particular port number, and if we don't expose port number of that server of that container, then we will not be able to access APIs from this container. Okay, so in order to verify which port number we need to expose, we will need to see the code. Okay, and in here you can see this is the port number this particular code is using, so we'll need to expose port number 8080. Okay, currently I'm keeping both port numbers same. So this is the port number of my launched instance, and this is the port number of the image. This is the port number of the container. Okay, so if you want to change this port number, you can do that, but for the sake of simplicity, I have kept both the same. Okay, and after that we will need to specify name. It's not mandatory, but it's a good habit, so I'm gonna keep it like app1. Okay, and the last part is you need to specify name of the image from which you want to create this container. So in our case it is, and that's it. We can hit enter, and now it is started creating our container. Okay, and let's create one more container with name app2, and this container is again serving APIs. So we will, but this time the difference is we will assign specific network, the network that we have created, and our network is mynet network, and since this is running on the same server, so we need to mention another port number. Okay, so let's run this again. All right, this is also running. So now currently we have two containers. One container is attached to default network and another container is attached to our private network. Okay, so now what I'll do here is I will create another container, and that container will be our Ubuntu container. Okay, and I'll show you what we're going to do with that, but before that let's quickly create it. Okay, and I'll assign our private network to this Ubuntu container. Okay, and let me use Ubuntu version 14.04, and I want to use bin bash. That's pretty much it. Let's enter. Alright, so our Ubuntu container is also ready. Okay, so now let me check all the containers. So as you can see here, now we have three different containers. Our first container is Ubuntu container, which we have just launched, and this we will use to ping our APIs. Okay, and then we have launched two different API servers, but the only difference between these two servers, the only difference between these two containers is one container, which is app1, is connected to default bridge network, and app2 container is attached to our private network. Okay, so let me show you our networks as well. So we have our default bridge network and we have our custom network. So let me inspect this bridge network again. So as you can see, our default network has one container attached. Okay, and this is the IP address of app1 container. And if I inspect our custom network, so as you can see, we have two containers. Okay, one is the app2 container, which is nothing but again the API server, okay, which is listening to port number 8081, and we have Ubuntu container. Okay, so the purpose of this example is if we try to access APIs of app2 container from Ubuntu container, then it should be able to access APIs because they both are on same network. But if Ubuntu container try to access APIs of app1 container, which is on a default network, it should not be able to access it. Okay, let's verify that as well. So what I'm going to do here is I will use docker attach command and I will use ub1 container. Okay, so now we are inside the Ubuntu container. Okay, so let me try to ping our app2 container, which is this, and this is the IP address of app2 container. So let me do that. app219.0.2. now if you can see here, we can ping our app2 container. Okay, there is no packet loss, we can easily ping our API. Okay, but if I try to ping our app1 container, and let's try to find out app1 container IP address, and now if I try to ping this particular IP address 172.17.0.2, 172.17.0.2, you see we cannot ping this IP address because our app1 container is on different network. Okay, so now here we learn if our container is on the same network, then and then only we can access our container. So let me quickly explain you what we have done here. So let me first list all the available containers. Okay, so here you can see we have created three containers: ub1, app2 and app1 container. Okay, so app1 container is our API server, which is attached to default network. Okay, this is attached to default bridge network. We have created app2 container from same image, but the only difference we kept is we've assigned our custom network to app2 container. Then we've created another Ubuntu container just to ping these containers. We have attached this Ubuntu container to our custom network. So now app2 and Ubuntu container is a part of same network, but app1 container is on the different network. And with this example, we've learned how we can assign network to any particular container. And the reason why I'm saying this is the real life scenario is because if you're creating web application and you have your backend server, you have your front end, you want to keep those containers as a part of same network, so that then only they will be able to communicate with each other. Okay, so I hope you have understood this entire concept. If you have any questions or queries, you can ask that in the comments. I think that's it for this video. Thank you very much for watching. See you in the next video. Bye.